design thinking approach, discussion on the emergency landing of an aircraft due to the asymmetric thrust or one engine failure condition. So now we have the brainstorming about this section. So we can use the design thinking 5 stages where we can discuss how to counterattack or how to balancing this case by avoiding the controls, stability and controls and flight dynamics operations in various issues that we can sort out, right? Let us take a case where the landing gear is failed or the one engine fail condition. How the lateral dynamic condition and the line dynamic conditions is affected for the airplane. So let us start with empathy.
Okay, when it comes to empathize, we should go on that side and think about it. So imagine that we are a pilot. We are a pilot who is responsible for the lives of the people, around 100 to 150 people in your aircraft. So when you take a plane and then you take off it, and then during the flight there's a engine failure in the twin engine. So the flight starts yawing very much. You can't control the yawing of the flight because the rudder also can't work on such situation. So how we can overcome this problem? How we can land the aircraft do a safety landing on that case? It's a quite challenging thing. So we should think about that. We should make some solutions to save the lives of the people that we work for.
So here the empathy of the pilot is felt very worst condition during the one engine failure condition. It is very difficult to operate in controlling the yawing moment as well as the rolling moment. Now as a part of the idea, in sense of engineer point of view, now we can discuss.
From the engineering point of view, when one engine fails, it creates a strong asymmetric thrust. So it creates a strong yawing moment. If an aircraft doesn't have enough rudder control or control surfaces allow directional movements, it can lead to damage. So the flight dynamics, we define stability as rudder control, aileron control to the rudder control. So it go in a straight movement. So like this, if we don't have the enough rudder and aileron control, or if it's too low, the aircraft could lead in a destruction or destroyed. It could be destroyed or crash landing. So our main challenge is how to improve directional and lateral stability of the aircraft in engine phase.
Now we will go to the next ideal stage.
We come to the ideal part of this problem. When we are thinking of the aerodynamist, we have enlarged the rudder and elevator part of the aircraft. We can increasing the control surface area to control the yawing moment of the aircraft. And the second, in the addition of, we can adding the thrusting technologies. Varying thrusters technologies are used to the aircraft. We can control the yawing motion and pitching and rolling motions. Even if it is an asymmetric conditions, we don't care about this. And we can additionally add to the flyby wire system. All the ideas are based on to maintain the aircraft stability. Even the thrust, even the improper thrust has been given by the aircraft. We cannot failure that part of the aircraft.
Now, what about the prototype condition? What can we use?
So first we probably go for structurals.
Okay.
I am opposing the same thing saying by the engineers. What about the structural dominance has been properly enforced? When you have maintaining to all systematic things, what comes to CG and what are the impact in tail and how automatically that can be flashed to all the crews. But in terms of condition, we need to focus on parallel of 50-50 chances. When we make up systematics fully, and we need to realistic and larger than of structures. So when we have a new type of wings or through our tails, making through all for the stabilities, not through totally convinced of safeties. Safety is major, but not totally convinced of systematic safeties. Need to was realistic of full-fledged loss. And thinking of full brainstorming, so the chances of 50-50 systematical has been much better, and even through structurals. When it comes structural, is more realistic and throughout all process of executions.
Okay, now we'll go for the final simulation or testing phase, so that we conclude the.
So to test these ideas, we can use simulation using the softwares. So we can use MATLAB Simulink to test these ideas. In the first simulation, we use the original configuration. In that, the engine fails and it yars uncontrollably and it loses its lateral stability. So to rectify this, in the second simulation, we can adjust the center of gravity and we can add a larger rudder and we can include the yaw damping controller. So by using this, we can reduce the yaw smoothly, and also we can reduce the control input by 30%.
So this was very nice interaction to sort out the